Well, welcome everyone, and we appreciate your time with us today. This is one of IPAF's educational webinars. We're pleased to have with us today Joe Brandel from MIPS. He is their business development manager for North America. He's a senior project manager. Uh, Joe is a subject matter expert, and he has been in the construction in industrial safety business for over 24 years, specializing in fall protection, hand protection, and head protection and other personal protective equipment. Joe's provided training and consulting for large and small companies throughout the Midwest. He also is a provider of solutions for a variety of industries, which have not only helped reduce cost, but most importantly, created safer work environments for employees. Today's presentation, we're going to focus in on head protection during mobile elevated work platform or MEWP operations and why it matters. So even those of us who can confess as being hard-headed, we all need head protection. And Joe's going to give us some information about how to select the appropriate head protection to keep you safe. So over to you, Joe.
Thanks, Tony, and thanks for the invite. Anna, thanks for your help as well. All the folks at IPAF for the invitation to do this presentation. As Tony said, my name is Joe Brandel. I'm with a company called MIPS. I've been in the industry actually 26 years and in the construction industrial safety. So this presentation will focus on head protection while using MEWPs and other elevated type platforms. And we're going to talk about head protection because there's been a lot of advancements, a lot of directives and recommendations from OSHA and ANSI, the standards. We'll go over that, over some stats. But if you do have any questions, feel free to add them to the question and answer portion, and we'll get to them at the end. So I'll get started. And again, my name is Joe Brandel. This slide says 25 years, but again, it's been 26 back in April. I've done training, as Tony said, in consulting for all kinds of companies in the Fortune 500, and even smaller ones as well. In that little photograph in the top left in the bubble, I've even done fall protection training for professional athletes. If any of you are NFL fans, the gentleman in the pink shirt is Peyton Manning, who won Super Bowl with the Denver Broncos and played with the Indianapolis Colts. And then the other guy there is our own Patrick Mahomes. I live in Kansas City, so therefore I'm a Chiefs fan. And that's a long story. But I did fall protection training for those folks in a film crew. So, fall protection is important for everyone because, you can slip, trip, and fall from an elevated surface, all over the place. So we're going to start with a lot of the OSHA standards. Then I'm going to go over a lot of stats relative to falls and head injuries and that sort of thing. But relative to construction, the OSHA standard for construction is 1926. And part of that standard relative to head protection gives directive to the users, to the employers, that they must provide head protection where there's a possibility of impact, possibility of shock burns, dropped objects, and that sort of thing. So, in essence, you as an employer have to provide head protection for your employees. That criteria, and OSHA doesn't do this a lot, but they included criteria for the standards for the head protection or the personal protective equipment. And within that criteria, they reference the ANSI standard. And for those of you that don't know who ANSI is, that's the American National Standards Institute. It's basically a private sector group that makes up the manufacturers, consultants, folks like that, safety professionals that sit on a board, a standards board, and make criteria for how head protection is manufactured, how it's tested, and therefore used in the marketplace. And like I said, OSHA, which is the government, makes rules and laws in order for employers to follow. And again, one of those relative to head protection is that you have to provide your employees with head protection that meets that ANSI standard. And the reason I bring that up is because, number one, it's a law and it's important and it's within OSHA. And I'm going to reference the ANSI standards because they're getting updated. They get updated every 7, 8, 10 years, and there's a new one coming out here pretty soon that will be updated, and it's an ANSI standard. So back to OSHA, they announced a bulletin back in November of 2023, and then they revised it back about a year ago in April of 24. They changed some language in it, but the original bulletin basically said that they recommend using safety helmets in lieu of hard hats in the workplace. And we'll get to a little bit deeper meaning or definition of what is meant by a safety helmet compared to a hard hat. But basically, in that recommendation bulletin, they said that, first and foremost, the employers have to do a risk assessment on their job sites to determine what type of head protection or all kinds of PPE, personal protective equipment, that they need or that the employees need. And then they also recommended one as far as saying that when head protection is needed, the employers should consider using safety helmets in lieu of or instead of traditional hard hats. So, when OSHA did that, there was a lot of confusion, a lot of questions about that, and rightly so. And OSHA went back and revised some of the verbiage in that revision. But the overall theme was they recommend employers using safety helmets in a variety of industries and applications. And I'll get to this slide real quick. Just generally, what is a safety helmet versus a hard hat? The safety helmet typically offers better protection. And we'll get into all of the ANSI standards and the types of protections and really how they differ a little bit later in the presentation. But this was from a study that Tony shared with me, and he came up with this slide, as far as the weight and how they differ and the side impact. The differences, again, between a safety helmet and a hard hat is the protection they offer. And as you can see by this slide, the helmet reduces the side impact, injury potential by 40% versus with a hard hat, it's 5 to 10%. And that has to do with how each of them are constructed and the type of material that's inside of each one. And the top injury reduction is 70 to 80% in both of them, whether it's a hard hat, which is typically an ANSI type 1, and then a safety helmet which is an ANSI type 2. Worker preference, they still prefer hard hats over helmets. There's a variety of reasons for that. It could be comfort, it could be the way the products look, and it could be just tradition. I mean, hard hats have been around for over 100 years. Safety helmets have really been in the market for just about 10 years. So it's good. The change is coming, but there's still some resistance to that adaptation. Accessories, they're definitely more. One advantage of safety helmets, as this slide indicates, is there's usually a lot better accessories, and I'm talking hearing protection like earmuff. I'm talking about visors. Other stuff that goes along with those accessories with the helmet. They're usually readily available, and they usually fit better on helmets versus hard hats. Discomfort in the summer, that's very subjective based on where you are in the world, really, and humidity, heat, and that sort of thing. So we'll get back to the OSHA recommendation based on that bulletin that they came out about a year and a half ago. And as you see in part of that recommendation in that bulletin, they came up with some recommended areas for use for safety helmets in lieu of hard hats. And one of them would be working for heights. That was number 3. You can read on the slide, and again, this is from the bulletin, construction sites. It's very broad. Construction sites, oil and gas, electrical work. So it covers a lot of different industries. But relative to today is number 3, working from heights, because the whole point of using a MEWP is you want to get an elevated surface to get something at a higher level that's not on the ground level. One of the reasons why I recommend helmets using a MEWP, whether it's a scissor lift or a articulated boom lift or any kind of an elevated surface platform, is because people take unnecessary risk. I got this photo off the internet of a gentleman doing something they should never do, which is standing on the top rails of a scissor lift. But again, this happens. I took this off the internet, but I've seen this even after I've done training where users, employees, workers, construction and industrial will do this just to save time, or they believe they're saving time and getting their work done faster. When in the end, this is extremely dangerous. I've been involved in incidents where folks have done this at work and have died because they've fallen off on and out of the lift. Again, this is not something the employee should do. And most of them know that, but they still do it and take shortcuts. And again, back to what I originally said, one of the reasons why I recommend using helmets in MEWPs is because people sometimes do this. And that helmet provides better protection and gives you a better opportunity for minimizing the injury and hopefully surviving it. So one of the things when it comes to a current ANSI standard, and again, ANSI stands for the American National Standards Institute. It's made up of the manufacturers of the head protection and other people as well. But part of that board is they create standards on how the products are tested, manufactured, and used. In the current ANSI standard for helmets and head protection or hard hats do not require you to use a chin strap unless the original helmet is fitted with that chin strap and the manufacturer recommends or requires it. So right now, as it sits today, chin straps are not required to be used. Now that will change in the upcoming ANSI standards. But again, we recommend it. I recommend anytime you use any type of head protection for that matter, that you use a chin strap with it. And the main reason why is it keeps that protective product, the helmet or the hard hat for that matter, on your head. In case of a fall, during a slip, trip, and fall, you fall out of an elevated surface, or like I said, even on the same surface, if that head protection product, a helmet or a hard hat, doesn't stay on your head, it's not doing you any good. So that's why we recommend it. And again, this slide shows that MEWPs aren't fitted with overhead protection systems. There's no cover. There's no protective system that you can really get on a work platform. So you need protection from dropped objects, from other things. And then the chin strap prevents, safety helmets falling to the floor. That helmet or hard hat could literally fall off your head. And if you're 50, 60, 100 feet in the air on a lift, it's going to generate a lot of velocity and therefore force if it, God forbid, were to hit somebody as a dropped object at the ground level. So again, the main point about a chin strap, and we get a lot of resistance to this in the marketplace, is the entire point of the chin strap is to keep that head protection product on your head in order to keep your head safe. So again, more information about the chin strap, compliance with site requirements. A lot of sites, a lot of job sites are requiring, to use an ANSI Type 2 helmet now. And almost all of them do have a chin strap included with them. And therefore, if the manufacturer of that safety product requires you to use the chin strap, then you need to use it. And a lot of that comes with training. You need to train your folks. Yes, if there's a chin strap on that helmet, it needs to be secured in order to keep that helmet on your head. And part of that is, again, as the slide says, part of that is the risk assessment. Is it a dropped object? Is it your helmet falling off? Is it, protecting your head in case of a slip, trip, or fall? And here's some of the data, and I'm going to go through this a little bit quick because it's very busy. The next few slides are making my point that falling from either an elevated surface or a slip, trip, and fall is very dangerous. And we've known that since OSHA's been around 1971. They've come out with stats for the construction industry specifically about how dangerous it is, and falls have been the number one or one of the leading causes of fatalities and injuries in the workplace. And again, on this data, lost time incidents by category, look at number one. It's falls from platform and stability, overturning, that the object, the lift could overturn. And, in my market where I'm from, I mentioned, I'm a Kansas City Chiefs fan. I'm from Kansas City. Over the 26 years I've been in the safety industry, there have been several accidents involving elevated platforms where there have been fatalities where somebody has been ejected out because they weren't using it correctly, or it overturned. Again, they weren't driving in an area where it should have been driven, and the operator ended up dying because of that. More data, that we get from the CDC and some other construction research organizations, between, and you can read this, between 2011 2019, a total of over 800 construction workers were killed basically by being struck by a falling object or equipment, getting run into, run over, or struck by a falling object. There was a case up in the New York area where a delivery driver was struck by a tape measure, and it deflected off the side of the delivery truck, and he ended up getting killed by that dropped object. In 2018 and 2020, an average of 376 construction workers died those years from slips, trips, and falls between those three years. So that's an average of almost 400 construction workers that die on the job due to falls, slips, trips, and falls. This is from the U.S. Bureau of Labor Statistics. In this graph, if you go back, I can get this graph, and basically when they started taking statistics way back, a couple decades ago, all the way until the present, but that curve pretty much stays the same. Falls are the number one leading, one of the leading causes of fatalities in construction. And within those causes of fatalities, a lot of it's due to head trauma because of that fall. And so, we believe that as a safety industry, most of us believe that using better head protection will help reduce these numbers. Again, more statistics. Falls on the same level, falls to a lower level, falls from collapsing structure or equipment. It could be a lift, could be other stuff, or falling through a hole, opening. In the graphic on the top right side, you see that falls are almost half the causes of traumatic brain injury in the workplace. There's traffic accidents, struck by, but again, those are all traumatic brain injuries and causes of those injuries here in the U.S. So we'll get into what is traumatic brain injury, or a TBI. It's an injury that basically affects how the brain functions. There are three different types of TBIs: mild, moderate, and severe. And within that compass, concussions are included in that type of traumatic brain injury. And these aren't work-related stats. This is just general stats. But over in the U.S. in 2020, and these numbers unfortunately stay about the same in the 60 to 70,000 range. Every year there are in 2020 specifically, there were over 64,000 traumatic brain injury related deaths in the U.S. Now, most of those were not work related. They were at home. They were in vehicle accidents. They were all kinds of accidents. They could be confrontation, all that sort of stuff. But over 64,000 traumatic brain injury related deaths here in the U.S. That, on average, that's just under 200 a day here in the U.S. There's another, I didn't include it in the stat, but there are over just under 750,000 hospitalizations, emergency room visits every year here in the U.S. due to traumatic brain injuries. And again, that's not all work related. Part of work related accidents are included in that, but most of it is outside of work. Again, it could be automobile accidents, could be falling off a ladder at home, could be falling off an elevated surface. It could be slipping on ice and hitting the back of your head. So, but the main point is hitting your head, traumatic brain injuries can lead to hospitalizations and can unfortunately lead to a lot of deaths. Some more stats. And again, I told you that we would go through these stats because it's important to see how impactful traumatic brain injuries are in construction. If you work for a smaller company, you're more than 2.5 times more likely than a larger company to die from a TBI. In my opinion, there's really no scientific answers behind that, but I think, a main reason is maybe resources. The larger companies have a lot more resources. Maybe they have a better safety program. Maybe they have better access to training or better personal protective equipment. I mean, there's a lot of different reasons for that, but that's a stat that has been true for a long time. You think of what type of workers in construction are more prone to TBI, fatal TBI accidents, and think about folks that work at heights: steel workers, iron workers, structural steel folks, roofers, whether they're residential roofers or industrial, roof companies. They have a higher fatal TBI rate than most others, again, because they're typically working on elevated surface and doing work that's higher risk. So, again, falls from ladders, lifts, scaffolds, that sort of thing lead to the majority of fatal work-related TBIs. And that's all research that other folks have done over the years. So folks say, one of the big drawbacks of converting from a standard ANSI Type 1 hard hat, which they do, I want to make that clear, ANSI Type 1 hard hat does provide protection, but it's typically just from overhead dropped objects. So part of the reason, the pushback for converting from that ANSI Type 1 hard hat that typically may cost $15, $20, $25 to a safety helmet, an ANSI Type 2 or an EN 12492 helmet, is cost, because they're going from a $20 hard hat now to a $100 helmet. That's a pretty dramatic, increase in cost to your safety budget, especially if you have hundreds or thousands of workers. And a lot of folks go, well, that's a big cost. Well, I direct them to an OSHA website, and they've got a calculator, and I put a link there on the slide. You can't click on it, but you can type that in. You can look at the OSHA website, and there is a calculator for each type of injury. And if you go through that calculator, you'll see the average direct cost according to OSHA, and they've done many studies, just directed to a concussion are almost $55,000, and that's one concussion. So if you've got hundreds of workers or even thousands or even dozens, one concussion is going to cost you almost $55,000. That's direct cost. That could pay for a lot of safety helmets. So, that again, better protection after you do that risk assessment, usually it's the best scenario to buy the best PPE you can buy. We'll get into some of the science behind head injuries. I work for a company called MIPS, and we'll get into the product that I promote and we make inside of helmets in a little bit. But the reason why our product provides protection is protection from something called rotational motion. And what that rotational motion is, it's a combination of rotational energy or angular velocity and angular acceleration. And basically, in essence, what that does is that the rotational motion causes your head to spin or your skull to spin, and therefore can potentially cause your brain to rotate and to spin and to move in a rotational motion, which causes a lot of dramatic injuries and traumatic brain injuries included in that. And that rotational motion causes something called strain in the brain. And we'll get into that in a little bit, how we measure it and how that's relative to traumatic brain injuries and concussion. And again, the reason why that rotational motion is important is because when human beings typically fall, or even when they're hit by something, it's not a linear impact. It's almost always at an angle. And that angular impact, that angular velocity, that angular acceleration can potentially cause that rotation in your brain, which causes the strain, which leads to the traumatic brain injury. We at MIPS have a virtual test lab, and we create scenarios to look at how the body functions, how the brain or how the head, basically as part of the body, what happens to it during different fall scenarios. And it takes a lot of time to set up these virtual test situations, but it's very impactful. If you look at the one that I'll show first, this is a person that's not working or that's not connected to any kind of fall protection, a harness and a connector and an anchor, and they're working in that elevated surface, and they end up falling. And they fall, and what you typically see in that scenario is that when they fall, that fall is leading to the head hitting at a different type of an angle, and it's almost always at an angle versus a linear impact. Sometimes that typical hard hat stays on, sometimes it doesn't, but we know with a chin strap, it's more likely to stay on. The images on the left, that was part of a video that a security camera caught in a power plant, and a gentleman, a maintenance worker, was doing some work inside that plant, and he was connected with wearing a harness and connected, and he fell, and during that fall, he basically fell and he impacted the side of that opening that he was working over. And one of the other scenarios that we have it on playing it now, hopefully you can see it, is a roof worker, or a maintenance worker falling off of an angled roof. And you see during that fall, the body, if you're lucky enough to hit face or feet first, you don't hit your head with as much impact, but your head will eventually impact the ground. And what happens is, again, it's not typically linear, it's typically at an angle, which again can induce rotation and strain in your brain. The last one I'll play, this particular one shows somebody that's connected with either a lanyard or an SRL or a rope and a rope grab. It stops the worker from hitting the ground, but what happens? They end up swing falling and hitting the vertical surface that they were working above. So just because the fall protection equipment stopped you from hitting the ground, it still may not, if you're not using it correctly, it can still introduce swing fall, which causes your body and usually your head to hit a vertical surface. So again, working at heights is a very dangerous and risky scenario, and you can get injured and die just from the falls related to that. You know, and another, we do some, work along with certain groups and stuff, and we've done other to get our research behind it, and just getting really awareness of brain injuries. And I came across this from the Brain Injury Association of US, and this is all public information. I've got the link there as part of my slide. They talk about why brain injury is referred to an invisible disability, because the way I see it, and according to this slide, and some of the information they've got on their website, you see the effects a lot of times of a brain injury, because sometimes it could cause permanent issues with vision, or the way your body functions, or a lack of the ability to function. But you can't actually see inside someone's skull. So you can't see what happened to the brain. So it's an invisible injury, but the disability, the effects of it are very clear, and can be, even if it's not a fatality, it can be a lifelong disability caused by that brain injury. So back to the rotational motion, how it affects brain injuries. Again, a typical safety helmet or a hard hat is designed and tested for linear straight impacts, whether that impact is on the side or the back of the front or at the top of the head. And we believe that most impacts, whether it's a dropped object or during a fall, do not occur on a linear straight impact. They're at an angled impact. And when you incur that impact at an angle, it can induce rotational motion, which therefore can cause brain injuries. And these are the type of injuries depending on the impact. Again, that linear, that perpendicular type of impact, what can it cause? What type of injuries can it cause on the skull and therefore in the brain? Well, obviously, if you get hit at a linear impact, it can cause a fracture of your skull. It can crack. It can actually crack your skull, which is obviously a dramatic injury. It can also cause what's called epidural hematoma, which in essence, that's basically bleeding on the surface of the brain and between the brain and the skull. And it can also cause a contusion, which in essence is, a bruise of the brain. When you hit something, a dropped object hits you at an angle or a tangential impact, it causes more severe injuries. And again, you can get a concussion due to that. That's due to the strain, we believe, that rotation has caused. You can also get what's called a subdural hematoma, which is bleeding inside the tissue of the brain, which causes swelling and a whole host of issues. But again, that's more internal, not just the epidural. It's on inside the tissue as well. And then it can also cause a diffuse axonal injury. And what the axons are the transmitters of information from your brain to the muscle or to the tissue or to the nerve. The axons transmit that information, and if you disrupt that transmission, it causes injury. It causes all kinds of issues related to how your body can function because of that. So again, my point is linear impact usually is not as severe as impact that is angle and tangential. That's by a dropped object or again by a fall. The way a lot of folks measure it is for skull fractures. For the skull fracture, again, is more peak transitional acceleration, or HIC, or head injury criteria. That's more stress in the skull bone. Not so much, measuring for concussion, it's measuring related to the skull fracture. What we believe is a little bit more in depth and therefore more accurate of a brain injury is called BRIC, brain injury criteria. We're measuring the peak angular velocity, or PAV, and we're also incorporating the peak transitional acceleration. We're measuring both. And, we're doing the X, Y, and Z axis when it comes to measurement with the sensors. Again, we're studying how the brain moves relative to that impact with a whole host of ways of doing it. And it's a combined probability of a concussion using the PTA. Again, that's peak transitional acceleration, as you can see on the slide, and the PAA, which is peak angular velocity. And what we're measuring, what we're looking for is strain in the brain. So this is a really good visual to show what I'm talking about even more when it comes to head impacts. So this is an FE, a finite element model simulation that is used in the automotive industry when they measure car crashes, the effectiveness of safety features inside those vehicles and how it impacts the body, specifically in this case to the brain. And if you see the arrow, if you can see the image on the left, that is a direct or a linear perpendicular impact that the head and therefore the brain impacts that surface during a fall or any kind of an impact. In the table on the right, what that's measuring is the severity of the strain inside the brain. It's a visual indicator that shows how much strain is being impacted in the brain. In the angle, or I mean the linear, the straight impact on the left that's playing, you'll see that color goes from the dark blue, which is neutral, all the way up to the greenish blue, so it's less severe. But if you look at the one on the right hand side, it's hitting that surface, that FE model of the brain, and the head is hitting that surface at about a 45-degree angle, which induces rotation. You can see that strain level again measured with on the right of the severity. Red is obviously the most severe, blue is neutral, no injury as well. You can see that those colors get very dramatic on the one on the right versus the one on the left. And again, we believe that's due to the brain actually rotating during that impact. So we use that information and we look at a study that was actually based on actual accidents and injuries. We had visual confirmation of the injury, we had medical confirmation, we saw the injury happen, and we saw the medical results and the studies behind it, and then we measured it. And we didn't. I mean, there was a study that was done based on those injuries. And what this study did is measure the probability of a concussion based on that strain level in the gray matter inside your brain. And so basically what the horizontal measurement of this graph is, of this slide, is measuring, again, the strain level in the brain, and then the probability of concussion from 0 to 100% is measured vertically on the left. And what you see is that if you get to the point of a strain level of a 0.26 strain level in the brain, you have a 50% probability of a concussion. And so what we try to do with our product, in addition to the other safety features of a helmet, is what we're trying to do is lower the strain level due to that rotation. And if we lower the potential strain level, we are dramatically lowering the probability of a concussion. Just if you go on the graph, and I'm not sure if my cursor is showing up, but if you just move just a little bit, if you go from 0.26 down to say 0.15, you drop your probability of concussion below 20%. You've cut that probability in less than half just by lowering the potential strain level in the brain. And that's what we do. That's what we do as MIPS. We've been around in all kinds of industries. We started in equestrian, have moved into the construction and industrial safety market about 4 years ago. And what we do is we make a low friction layer that goes inside of the safety helmet. And what it does is protect your brain from the forces, the rotational forces that are transferred to the head by the impact, or when your head impacts a surface. And we're only talking about a protection it allows a 10 to 15 millimeter. It's a very small movement, relative movement between the helmet and your head during that impact. And we're talking a very, very brief 5 to 10 milliseconds of impact. A blink of an eye is 100 milliseconds. So think of how quick 5 to 10 milliseconds is. It happens extremely quickly, and we're trying to, again, allow that 10 to 15 millimeters of relative movement of that helmet moving instead of your skull, and therefore instead of your brain. So a lot of folks will think, okay, I've got a hard hat, I've worn it for years, it's got a suspension system in it, and they believe that will allow the helmet to move during that impact. Well, that's not necessarily true, because when you hit your head on a surface, or if something hits your head from above or a dropped object, it generates force. And back from my fall protection training days, we used to drop a 220-pound weight. Well, the more distance that weight drops, the more pounds of force we're generating. Therefore, that's when it comes to fall protection, that's what the shock absorbers inside the SRL or the lanyard or the rope grab, that's what it was protecting you from, the force. Well, that same force can be applied to your head. And as the slide points out, it can be over a ton of force when something's dropping onto your head or when you hit your head on the surface. So just because you have a basic standard suspension system in your hard hat, it's not going to allow for that relative movement that's protecting you from that rotation. You need some sort of system like our MIPS low friction layer inside that helmet or hard hat in order to allow that to move instead of your brain. A better visual of it is, than me talking about it, is a snow globe. When you take a snow globe and you move it at a linear impact, the snow inside the snow globe doesn't move. But as you see in the video, when you start to rotate that snow globe, it obviously stirs up all the snow inside of it, just like your head, your brain would do inside of your head during an oblique impact. And again, part of that is our brains are surrounded by cerebral spinal fluid, and that acts as a shock absorber for linear impacts. If you think of a boxer or an MMA fighter, when they take a direct linear hit, it doesn't impact them. But when they get hit on their chin or on the side of their head, or God forbid on the back of their head, it can reduce rotational energy into the brain and cause severe traumatic brain injury. So let's talk about hard hats. So hard hats have been around for a long time, over 100 years. Ed Bullard of the Bullard Company basically was the one that invented it. They boiled leather and created the hard hat for the shipyard building industry for the World War I. It carried over into into the industry for different applications. The Bullard Company put an inner suspension in that, again, for basically dropped objects, overhead impacts. That's what that suspension's for. They moved from leather. They moved to aluminum. Aluminum's conductive and it can be expensive. So then they went into fiberglass. Fiberglass, again, there's issues with it. It's not as strong. And then lo and behold, in the 50s, they came up with, MSA really perfected it and came up with their V-Guard, an injection molded plastic hard hat. And that's been around for well over, over my lifetime. It's, 65, 70 years. That's been traditionally what we've used. In the last 60 years, in the last 10 years, we've moved towards that safety helmet, the ANSI rated safety helmet, again, for better protection. But some of the benefits of it is, again, like I mentioned in one of the first slides, one of the benefits of using a helmet is, number one, a chin strap, so it stays on your head. But some of this accessories, as you see the eyewear and the hearing protection, seem to work better, and the face shield seem to work better with the safety helmets. When it comes to testing relative to head protection, the International Safety Equipment Association, or ISEA, again, that's the parent or the governing body that is over ANSI, but ANSI has this specific standard, and ANSI is American National Standards Institute. That's the board that makes up the standards on how these head protection products are tested. And I'm going to go through that real quick. On the left, you have an ANSI Type 1, a current ANSI Type 1. And again, the revision is 2019. As you can see on the slide, it's ANSI Z 89.1-2014. Again, last revision was 2019. And it will be one, I was told, come out sometime this calendar year of 2025. And that's ANSI Type 2. And then the European standard, the European version of ANSI is the EN standard. And that's commonly the 12492, or that's a mountaineering type standard. But I want to talk about how each one is tested because that's common in the workplace. ANSI Type 1 is, again, only tested for overhead shock and impact and penetration. Where's the test zone? It's at the top of your head. So that's all that an ANSI Type 1 hard hat is designed and tested for protection, for overhead dropped objects. And ANSI Type 2 is basically for side impact, and again, top impact as well. ANSI Type 2 does pass the ANSI Type 1 standard of top impact overhead impact, but also side impact as well. And again, you see the test zone. And the reason I like this graphic is because it shows you the test zone for each one. The EN 12492 is a mountaineering standard. It's really not an industrial helmet standard with an EN 397. It's its own standard. And again, it's tested for side impact. What it does not do, as you can see on the test zone graphic, where the green little the part is on the graphic of a human head, it does not go as far down as the ANSI standard for type 2. So again, it provides protection, but it's just tested differently. That's where a lot of confusion lies, is where is the ANSI, the EN 12492 compared to ANSI type 2? It's basically the impact zone, the test zones. So that's the difference. So, that's what you need to do when you're working in a MEWP or working in the elevated surface or have the potential for a slip, trip, and fall where you can impact your head either from a dropped object or your head impacting something, a surface or a lower surface. You need to provide your employees with the best head protection possible. And that's basically it. You have a lot of available resources through IPAF and through MIPS for that matter, that we can help you, for training, for education, for that sort of thing. If it still is very confusing. One of the requirements people ask me about the EN 1249 or the ANSI standard type 2 is the current standard, does it require having a chin strap on the helmet? And the answer is no, unless the manufacturer provides it and requires it to be used with it. But right now, the ANSI type 2 standard as it sits on its own does not require a chin strap. We believe that will change in the revision that's coming out this year. So are there any questions or any comments or any need for clarification? Do you see anything, Tony?
Since there's no questions currently up there, Joe, but I do have this question, which, again, is uh, for those of you on this call, MIPS is this insert that goes into these helmets. So do people, how does the MIPS get integrated into the type 2? And are there type 2s out there without MIPS in them? Because when I first looked at it, I said, geez, I want to get me a MIPS helmet. And
Right.
you're not a manufacturer. MIPS is not a
Nope.
helmet. MIPS is an insert into the helmet. So if you could talk about that a little bit, because that'll help us understand this rotation and how your protects for that, and what the options are out in the marketplace.
Yeah, that's great. Yeah, that's very good clarification needed because we as MIPS do not make any helmets, as Tony said, and we've been in the sporting goods industry. If you go into a sporting goods store and buy a bike helmet, the majority of them have MIPS in it. And what we do is we incorporate our low friction layer. It's usually yellow. We do make it in other configurations, but it's a yellow low friction layer that sits in between your head and the head protection product, whether it's a foam layer that provides a protection or a suspension inside the hard hat. Ours sits on top of your head while you're using that. So it's a component of it. The answer is yes. When you asked about are there type 2 helmets without MIPS, there are. We believe that when you incorporate our low friction layer, we provide a better or higher protection level because we're protecting you from the effects of rotational motion. And that's testing that's been done for over 20 years that we've done in a variety of situations. We've done over 90,000 tests in our labs that we have, and even third-party tests that have verified our testing. So does that answer your question?
Yeah, it does. So secondly is if someone wanted to buy a device or a head protection with MIPS in it, how do they go about finding that? Because it's not like I'm going to go to the store and say, give me a MIPS helmet.
Right.
So
Yeah.
how do they identify that?
Yeah, that's a great question. So we have a website called mipsprotection.com, and you can go there and see all of our partners. And again, we've got sporting goods products on there as well, but we do have construction safety, and that link will link you to our partners. But we have 8 partners right now here in the U.S. and worldwide. It's over a dozen because there are helmet manufacturers all over the world. But here in the US, we work with Protective Industrial Products or PIP. We work with MSA, Hex Armor. We also work with Ergodyne, a company called Securus. And, we also have a company called ERB or Delta Plus that has as well. So Camp Safety that also that's available here in the U.S. And we're getting ready to launch some more partnerships. Company called Pyramix is going to launch their product here pretty soon to the marketplace. It's going through testing in some of those phases, but yeah, we're launching even more partnerships here in the U.S. So you can look at those brands, or you can get a hold of look on our website as well. Again, that's MIPS MIPS protection.com.
All right. So any of those attendees, if you have any questions, please just hit the Q&A button and type those in. And Joe, I do have another question because, for me, I've been for a long period of time thinking about us being safe, and you just go to, any hardware store and you buy a hard hat and you put it on and you think you're safe. And
Right.
that was really the thing that most impacted me from my awareness of your system and the information you're providing me, which is, you know, is it really providing you with the safety that you really need? I mean, I go through and look at the OSHA fat cat reports and information that's out there, and I'll give you an example. I look at them for aerial work platforms, and there was an incident that occurred September of 2024. An employee was working for an aluminum processing facility, working off a scissor lift, performing maintenance on a conveyor belt while working from the lift. An anode hit the scissor lift and knocked it over. As the lift fell, the employee grabbed onto a bar and was hanging until he lost his grip and fell approximately 15 feet, transported to the hospital, and died of head trauma.
Yeah.
So, while we think about mobile elevated work platforms and safety, and we think about guardrails and we think about wearing personal fall protection, um, you know, the level of protection that we're giving them, because when I'm going over and we keep raising the bar to provide additional protection when we see incidents continue to occur, this is striking to me on the level of added protection that is missing when we just go and buy that $20 hard hat.
Yeah.
And I think that I really applaud what MIPS has brought to the marketplace, and I really do think that this is something that we need to raise more awareness on to provide that protection. So looking at a hard hat, and I'm just asked this, and I'm not sure whether you can answer this. I often see the construction workers taking the hard hat, and oftentimes, just like a baseball cap, to flip it in reverse with the brim in the back. When they do that, does that diminish, even with that, the safety of that?
It, it really depends on the manufacturer. They have to go back, whether it's whatever type of personal protective equipment it is, whether it's a harness or a glove or whatever, a helmet. If there are some very few models that do allow that, but they're very few, but you have to go back to the instructions and the manufacturer for that individual product, and if it will allow for what's called reverse donning,
Yeah,
to allow.
dominantly, you would agree that it's not intended for that, and it lowers their protection.
Oh, no doubt. I mean, especially the way our system sits in a typical ANSI Type 2 helmet is you've got a layer of foam, usually EPS, and then we sit up on top of that. So it's designed and tested for that forward-facing helmet. So really, there's no model that we're in right now that allows that. But I know there's a few on the market, and none of them have MIPS that do allow for what's called reverse donning. And again, it's very, very few, and you've got to make sure that that individual manufacturer allows it. In fact, there's a little symbol that ANSI has as part of their requirements for labeling, and it shows if it's allowed to be reverse donned or worn backwards.
Again, this intrigues me. The movement to increase safety. I go out there and say, with an aerial work platform, mobile elevated work platform, MEWP. When we go over there, we really talk about proper MEWP selection is really critical to safe operation of the equipment,
No doubt.
for lots of different reasons. And within that standard, we also say, and uh, I'm going to say additional accessories that go with it. And so when we talk about it, an obvious one is personal fall protection. Hard hats are one where we really don't get into a lot of discussion, although we typically, every time we're out there, promoting the safe use of it, we do recommend the use of a hard hat.
Yeah.
So now we're looking at it, and I'm using the word hard hat, and the distinguishing part here is a hard hat doesn't require a chin strap, where as helmets do. Is that correct?
Generally, I mean, again, most of the helmet manufacturers that we work with do require you to wear your chin strap. In fact, we require it. If you put our system into one of your products, that's a big requirement. Is it has to have incorporated chin strap, and the user has to wear it because it will not do you. I don't care if it's our system or just the helmet itself. It's not going to do the user any good if it's not on their head. If your head gets impacted by an object or they fall, and your head gets impacted during that fall, if that product is not on your head, it does you zero good. And there have been fatalities. There's several large construction companies here in the U.S. One of the biggest reasons they went to better head protection is because there were scenarios that I just laid out, whether they had a worker fall off a ladder and their traditional hard hat fell off. The worker hit their head on the concrete and they ended up dying. They fell off of scaffold. They fell off of an elevated platform. And again, that head protection product didn't stay on their head. Therefore, when they hit, it was a traumatic brain injury, which led to a death. Part of the financial benefits of using better safety products, whether it's a head protection product or could be a harness or boots, is to cut down on the injuries, because injuries and fatalities are very expensive. You've got insurance cost, hospitalization, lost work, investigation cost. So, I mean, that's driving a lot of that industry, mainly the construction industry right now, but others are looking into it just from, obviously they want to protect their employees, but they also want to reduce injuries because of the cost related to those. And the best way to do it is to, follow the advancements of that head protection. You know,
And,
one
and
of
I,
the one of the when I do a lot of training, especially in the construction field still, and I've done it for a long time. And when I get to lifts, when I get to mutes, there's been, and I sold fall protection for a long time, harnesses and connectors. And for years and years, we were told that in an articulated boom lift, to use an SRL because it'll lock up and it'll keep that worker, if they were to go on an uneven surface and that boom starts moving violently, it'll keep them from getting ejected out. Well, that industry generally is switching back to no, we don't want you to use an SRL, a self-retracting lifeline. We want you to go back to using restraint, like we recommend in scissor lifts, to keep that worker on their feet on the platform instead of, because the potential with a self-retracting lifeline is it allows you potentially, again, potentially, to get ejected out of the basket. Maybe you don't hit the ground, but you still get ejected and you could hit your head on the rails or the platform because it allowed you to get outside that basket. Again, you didn't hit the ground, but you still got injured because it allowed you to leave the basket. So I was just on two webinars related recently and heard a speaker talk about some of the changes in recommendation just one as part of that. So, fall protection is different than head protection, but they're incorporating both. Again, how many times did I say today, and you even said it, falls lead to the head injuries, which cause the traumatic brain injuries and a lot of fatalities.
Joe, I would add that, personally, my awareness of the issue of helmets, became really prominent with the NFL, with concussions, so you're looking at saying, oh yeah, I have this head protection device on, but it's proven that it may not be as effective. So new technology is going that direction. I remember when I was a kid and we were riding bikes, the best head protection we had back then was a baseball cap. But no, nobody have anything else. And today it's almost like there's rules out there that if you're going to be riding a bike, you must be wearing a helmet.
Right.
And as I'm seeing that movement, and you're in that space, I'm wondering whether there's any statistics out there about, within those industries of how significantly we've reduced incidents, concussions, head injuries by moving to this new technology.
Yeah, it's dramatic. It reduces the injuries dramatically. The contractors and even the industrial folks that have moved to the better head protection have seen their injuries decline dramatically because of the use of that. After the enforcement, there's problems. I shouldn't say problem. There's challenges with implementation on whatever new type of safety equipment, and once those are solved within that group, the injuries go down dramatically.
Thank you. I have not seen any questions coming from our
Yes,
attendees, so
hi
yeah.
Tony, we have one from TJ.
Oh, thank you. Okay,
It
here's one
says,
from TJ
okay.
Lyons. Do you see the potential for injury litigation if a helmet is not worn when it would have provided better protection than a standard helmet?
Yeah,
So,
it's a pretty broad question. I mean, if it wasn't being worn or worn correctly, I could see potentially, yeah, that being an issue. Or, if maybe the employer didn't provide, the proper protection based on their risk assessment if they do one, and they didn't provide the proper, PPE. And it's not just head protection; it could be any, um, you know, personal protective equipment. I mean, there's a potential of litigation in anything if it's not provided. If the proper safety equipment isn't provided, there is potential litigation if there's a
I,
injury or.
I, I guess I would compliment TJ's question by saying, have you seen any incident where it's saying you wore a hard hat rather than a
Oh,
safety helmet?
I again, this is just my educated guess after, over 2 decades in the business. I don't think we're there yet, but if it again, if your risk assessment showed that you should have been wearing or providing a helmet over that hard hat because of the risk for oblique injury or side impact, linear impact, then I could potentially see that.
All right. Another question is do you see a time when OSHA eliminates through regulations the use of type 1 hard hats?
I get that question a lot, and that's a very good question. I don't know if they'll ever go that far, and I can't speak for OSHA because I've never worked for them or been part of the government. But I mean, Type One hard hats do have a place in the market. If you do the risk assessment, and really the only risk that you have is from dropped objects, and don't have that risk of a slip, trip, and a fall, then the ANSI Type One hard hats are completely adequate. So to say that OSHA will ever stay completely away from it, I would doubt it. I mean, I highly doubt it because again, they're putting the onus on the employer to do a risk assessment. What are the risks of head injury? What are the risks of all the potential injury? And you have to go through that for each site, for each employee work area. So long-winded
How,
answer,
how,
I
how,
would,
how-
I
yeah,
would say no.
I would agree with you, Joe. But I also would go out there and say the fact that they put a letter out which recommends wearing a helmet, I
Yeah,
think from a litigation standpoint, puts a lot more emphasis on using a helmet today than it did prior to that. And I
right.
think that, and I think that the awareness of this topic, even for me, I've been in this industry for like 5 decades. I'm coming over saying this is kind of an epiphany moment on head protection.
Right. It is. I mean, the last decade have been dramatic movement in the industry for head protection. It puzzles me that this segment has taken so long because I can't think of any part of the body that's more important than the head because it encompasses your brain. Well, your brain makes every other part of your body works. So I mean, we need to protect it first, because if you don't, then you're going to have issues. So it's kind of puzzling if you think about it, why it's taken this long to get these sort of advancements with this category of personal protective equipment.
Okay, there are no other questions. We've concluded our 1 hour time limit. Just as you see on our work or on our slide right now, IPAF is holding a in-person work at Hythe Conference and Awards, October 15th and 16th in Nashville. Please, if you enjoyed this educational portion of our education for you, there'll be lots of other opportunities at that event. So please make sure that you put it on your list of things to do. Joe, greatly appreciate your willingness and the information that you provided us today. I think that it's invaluable, and that concludes our session. Thank you all.
Thanks, Tony. Thanks, Anna.